Alright, example 7 starts off a few examples here where we're given a graph and we actually need to write the equation of this thing. Now, what you will be given most oftentimes is the value of b. That can be a little bit hard to discern. We're going to try to do that though just by hand here and see if we can extend those asymptotes. And this graph is a little bit big. So I'll try to move this up just a little bit for you. Maybe we can get the whole thing in there. That looks pretty good right there maybe. And we'll scoot it over just a touch. Okay, so the very first thing with these things, writing the equation, is to find the center. If we find each one of the vertices first, then we can just go halfway in between and find the center. This one opens up and down, so our y term is going to come first. And we don't have to add or subtract anything to y, so we can just do y squared over, we're not sure yet. It's a hyperbola, so we're definitely going to have a minus sign. And then the x minus 0 is going to come next, or just x squared. That's equal to 1. The next thing we need to do is find out the value of a. So that's just this distance here between the center and one of the vertices, either one. And so that distance is 2. So we'll square it, and that's going to be 4. Remember, a squared always goes under the first term, and b squared will always go under the next one. To find b, we need to find those asymptotes. So I'm not sure if the ruler I have is going to do it. This is kind of a little bit short of a ruler, just a 6-inch ruler. But maybe we can kind of figure out where that's going to be. If we do this, if we make it, let's go right here. Let's see if that's going to make it or not. So if we extended that, it looks like that would be a good one. And then if we did the same thing on this side, if we just tried to get close to each end, you know, we can't cross each end, but we need to get close to it. So we're going to have something like this. Oops. And you can tell that each one of these asymptotes, if we were to take a line here through each one of the vertices, each one of those asymptotes is going to go right through these points right here. So to find b is just going to be the distance that is formed on the conjugate axis right here. So I should have put an a over here, I guess. That would have been helpful. And then a b. The b would be just this distance from the center out to the edge of this square, or in this case it's a square, but of that rectangle. So b in this case is also going to be 2. So this is an interesting hyperbola that where a and b are exactly the same, and that's okay. That's fine if that happens, no big deal. If that happened in an ellipse, that would just be a circle, but this is definitely not. We've got a minus sign hanging out in here. So all the instructions said were to write the equation of the hyperbola in standard form, and this is it.